Okay, and for 12.5 honors class, we're going to do some systems of equations. You will see systems of equations back in Algebra 2 if you choose to take honors or even regular. But again, in Algebra 2, they might get into some nonlinear systems. You might have even done that in Algebra 1. So what we're doing here is we're looking at a circle and we're looking at a line, and we're trying to see where they intersect. When you solve a system, you're taking your two equations or more and trying to find where they intersect at. So to do this, we're going to use a process called substitution, right? Substitution. So the first thing is you have to solve one of these equations for a variable. Well, this bottom one, this line is easy to solve for. The y has a positive 1 coefficient, so get the y by itself by adding 2x. So you get the 2x's to cancel, so y equals, if you want to put the 2x in front like your normal slope-intercept form, that's fine. You can also put it back, but there you go, y is by itself. Do you always have to solve for y? No. If the x has a 1 coefficient, then you move the y term, okay? All right. And now here's where the substitution comes into play, because now that y equals 2x plus 7, 2x plus 7 can be substituted in for y right there. And that's what we're going to do. So we're going to rewrite that top equation, x squared plus, but now inside the parenthesis, instead of the y, we're going to put 2x plus 7 plus 3 squared equals 65. So this 7 plus 3 becomes plus 10. And now 2x plus 10 quantity squared, we need to actually write that out. So 2x plus 10 times 2x plus 10. And we're going to multiply this out. The 2x goes to the 2x and the 10. 2x times 2x is 4x squared. 2x times 10 is 20x. Then we multiply the 10 by both. 10 times 2x is 20x, and 10 times 10 is 100. And now we combine those middle terms, 4x squared plus 40x plus 100. That is what this binomial squared turns out to be. We're going to also bring down the x squared plus, and we're going to bring down the e equals 65. And now we need to solve this like the quadratic that we know how to. So the first thing is I'm going to simplify the x squared and the 4x squared, so that's 5x squared. And then I'm also going to bring the 65 over at the same time by subtracting it, because I need to make one side become 0. So it does not change the 40x, but 100 minus 65 is plus 35. And now that it's equal to 0, now I have to look to factor it. Now the first thing I would do, because there's a value in front of the x squared, is I would look to divide by a common factor. All of these numbers are divisible by 5. Lucky us. Let's divide by 5, divide by 5, divide by 5, divide by 5. And we get x squared plus 8x plus 7 equals 0. And now in this set of problems that says line 1, they all should be pretty easily factorable. So we're going to factor it into two sets of parentheses. So how do we determine this? So let me refresh your memory, because I think I showed you this once before. So you look at the c. Okay, first of all, how do you get x squared, x and x? Sorry. And then for the signs, you look at the c. If c is positive, they're the same signs. If c is negative, you just put a positive and a negative and you go about your business. But since c is positive, they're the same signs. So then you look at b to get what those signs will be. And because b is positive, they'll both be positive. And now it's the factors of c that make b. So 7's factors are 1 and 7. Just assign the signs, plus 1 plus 7. That does give me positive 8. And that's my answer, plus 1 and plus 7. Set each of those equal to 0. And solve by subtracting 1, x equals negative 1, and subtracting 7, x equals negative 7. Okay, and that is not a point. That is not the point, negative 1, negative 7, because they're both x's, right? Each of those is an x. We need to find the y that goes along with them. The way that we're going to do that is we're going to take this step right here that we solved for y and plug in our x values. So y equals 2 times negative 1 plus 7. That's negative 2 plus 7, that's 5. So one of our solutions is negative 1, 5. We'll do the same thing with the negative 7. Y equals 2 times negative 7 plus 7. That's negative 14 plus 7. That's negative 7. So another solution is I'm sorry, -7, -7. And we have two answers, so we have two solutions, -1, 5, and -7, -7. And that's what we're going to put in. So two solutions, uh, -1, 5, and then -7. I'm sorry, -7, -7. Let's see how I did. Nice, and there's the green check mark. So let me do a favor. Let's go into Desmos Graphing Calculator. Let's graph this. All right. So I want you to practice the algebra, but really you could do this by just graphing it, if you know. But again, practice the algebra. So over here, I'm going to type in my formula: x squared plus y plus 3 squared plus, or no, equals 65. There's my circle. I'm going to zoom out one. Again, I like to count by the 5 and 10. And then over here, I'm going to type in the original: -2x plus y, -2x plus y equals 7. There's your line. And now look, one of the intersection points right there is -1, 5. The other one is -7, -7. So in this situation, there were two solutions. This is a secant line going through a circle. Sometimes you can have a tangent line, meaning only one point intersects the circle. And then at other times, you could have no solutions. That means the line and circle are completely separate. Okay. So as you work through these problems, if you get to the factoring and it gets kind of strange, at that moment, I give you permission to graph it and see what it looks like. Okay. So this was the easier example because the solutions were pretty nice numbers. I'm going to do a level 2 one that's going to get a little more difficult. All right. So stay tuned to that video.